Assalamu alaikum wa rahmatullahi wa barakatuh. Good evening to everyone. Before we beginning, I will express my thankful to everyone who contribute to this conference for providing this available platform for knowledge information. My name is Ebtehal Alharbi, and today I'm very excited to share our research of evaluation of genetic features of disease in multiple myeloma via bioinformatics. This research explore the genetic aspect of relapse in multiple myeloma. So let's start. Multiple myeloma is hematologic malignancy. Multiple myeloma is hematologic malignancy characterized by uncontrolled proliferation of plasma cells in bone marrow. Despite advances in treatment, relapse remains a significant challenge. In our study, by using bioinformatic tools, which powerful tools as they analyze large amount of gene expression data from diverse patient population, while a proposed study refers to genetic alteration in multiple myeloma, the specific gene that contributed to the relapsing multiple myeloma remain poorly understood. To address this, in our research, we aim to uncover unique genetic signatures that enhance the recurrence of disease and to target potential therapeutic. So to achieve our goal, we do this. First, we collected our sample from publicly available gene expression omnias, focusing on that with bone marrow data and at diagnosis and relapse stage. This gives us a 3 valuable data set, and the collected sample were pre-processed and the differentially expressed gene identified by using ALT analyzer tool. Then the heat map was generated to represent the most upregulated and downregulated gene, and the ALT differentially expressed gene subjected into functional enrichment analysis in order to understand their biological implication. Finally, we use the Kaplan-Meier plotter to evaluate the prognostic value of identified gene in multiple myeloma patients. So this is our result. According to criteria, patient sample and diagnosis and relapse, we selected a total 170 samples, among of them 105 at diagnosis stage and 65 at relapse stage. So these samples were processed and merged from these 3 data sets, and our result refers to a total 12,486 genes. Among of these differentially expressed genes, according to criteria fold chain more than 1.5 and p-value less than 0.05, we identified 822 upregulated genes and 62 downregulated genes. Among of the upregulated genes, 75 stringes to criteria fold chain more than 2. So this heat map represents the most upregulated and downregulated gene suspected on relapsing compared to diagnosis multiple myeloma patient. For example, the top upregulated gene, LYZ, is 100AB and MDM4. The overexpression of this gene may be response to disease progression or drug resistance. To get more insight into understand the biological of this disease, all the differentially expressed gene identify in the KIG pathway. 3 of this pathway significantly enriched, which FOXO signaling pathway, P13 AKT signaling pathway, and mTOR signaling pathway. This represents the potential pathway to target or use as a prognostic value to prognostic marker to identify relapse. So using a database, we search in database to a number of genes who overexpressed in our analysis, and we identify this list of genes which correlate with the prognosis of patient. The overexpression of this gene correlate to high survival of gene. However, S100AB and LYZ are not of them. For example, the expression of CKS2 effectively differential between 2 groups of patients. The dark color is represent the 1,033 sample diagnosis sample, and the red color represent the 383 relapse sample. So this differential of this gene is distinguished between, highlights the distinguish between two groups of patients. So in summary, our study uncovered significant insight into the genetic landscape of relapsing multiple myeloma. We identify this specific gene, LYZ, S100AB, NAB1, and so on, as, and we highlight a three enrichment pathway: FOXO signaling pathway, and mTOR signaling pathway, and B113K AKT pathway. So this highlight should to understand the molecular mechanism of relapsing multiple myeloma. In conclusion, our study is contributed to advances multiple myeloma, and we hope this finding improvement the treatment of the patient who affected of individual who affected of this hematologic malignancy. And finally, my heartfelt thanks to my university, Qasim University, and to my supervisor, Dr. Abdel Mahsen Al-Ruwaitei. His expert and education contribute to success of this work. And I want to thank for every one of you to presence here today. Thank you very much.